Okay, so the end or the fixed jaw, whatever we want to call it, probably the end. We're going to introduce configurations. It's a fairly simple part, and there's more that we're going to be able to do with configurations in the future. So basically, a rectangle, the three holes for the counter bores to clear the M5, the two holes to mount. There's really no reason not to make these through holes, and the advantage would be from a manufacturing cost is that I could, let's see, thickness on this is 15. Should be pretty close to being able to run a tap all the way through if I needed to. We haven't really discussed materials and the sizes, but let's see if I can get that one going. But if I make this a blind hole from the other side, then in the manufacturing, I have to drill and countersink from this side, turn it over, and drill and tap from the other side. I don't see an advantage in that. So I'm going to go ahead and put these two holes all the way through from that same side. So File, New, Part Metric, Front Plane, Sketch. We'll get out of the center and just go back to corner rectangle. Pick our point for the origin. Control select the line, go to midpoint. Add a few dimensions, 55 millimeters, 45 millimeters overall. And then we can extrude that out to 15 millimeters. And I want to reverse the direction. Oh, that went mid-plane. No help there for mid-plane. So we'll just put in the 15 millimeters and call it good. All right, so picking the face, going into the hole wizard, picking a counter bore. We're in the ANSI metric, and the important one here is a hex bolt has a much bigger head than the socketed cap screw. So once we go into the socketed cap screw, then it's dated M5. We want to show the custom sizing, so the 5.8. They went 10.4. I don't know that that's going to be enough of a difference. And then the 5 millimeters, I think I mentioned previously as a general rule, the diameter of the thread is also the height of the socketed cap screw. Up to next is fine, and the head clearance of 0.2 or 0.3 should be plenty. All right, and then going back to this, if this changes, if I decided I needed to change those over to M6, this could change, but the 0.2 head clearance would be somewhat independent. So grab our points, right click and select. I can window pick and make horizontal. Select the origin, control select the center hole location and make that vertical. So if we're going to dimension in the same scheme that we did previously, I'll just stay with the 19.5 and the 19.5. And we are 8 millimeters from the bottom. Okay, we accept that one. And when I select the bottom face, hold down the control button, select the top face. Down here I can do a quick verification that it did go to 5.2, or we can go over to evaluate and measure real quick, and it shows me that the normal distance is 5.2. All right, so instead I'm going to put the 5 millimeters from this side, and when you get back into features, go into the hole wizard. Apparently I turned my rotate off because it didn't do it again. So Control 8 will put me normal to the sketch. A straight tap M5.8 up to next. And the only consideration, well, one of the considerations here is that taps only have a certain amount of engagement, and neck down taps even only have a certain amount of engagement that even if it's relieved, I'm probably not going to get more than 20-25 millimeters. Realistically, an inch is pushing it. And with the chip that this is going to generate and the thread pressures, all of those kinds of things, at some point we're going to have to take into consideration tap breakage and how many parts we'll lose. All right, so center line from the origin to the midpoint. And then we can window pick, and those become symmetric now. Since I added both points, since I did not go into the mirror, now I'm telling it I want those to be symmetric instead. So same thing, they're ending up with the same results. It's just a slightly different way of getting there. All right, and then centering across the two hole locations, that was our 35. We go ahead and hit escape. So at this point we have a couple of options. If I call this my my vise fixed jaw, and it's not really a jaw, but the fixed jaw is fine. All right, so at this point I could make a configuration, suppress these holes, put the part in, and don't have to redraw anything. The other option is to go right into Save As and reuse. So let's see if we can shrink this down just a little bit. I want to save as copy and open. And then this one would just become the vise maybe fixed end. All right, so at this point, I don't need the original document just yet. So I'll go ahead and close it. And here's where the configuration comes in. I can suppress, which means that those tapped holes are still there, they're still available, they just aren't participating at this point. So if we come back over here and close that, then this was 10 millimeters from the top and on center. So I want to do that same thing here with the M12 by 1.75. So pre-selecting the face, hole wizard, tapped hole, and M12 by 1.75. All right, so that's a fairly coarse thread. The higher numbers is going to be a wider pitch. Okay, and then up to next is good. We'll look for the center line. Said that we were 10 millimeters from the top, but stack up wise, knowing where that is, that's something that I'm going to want to check when I get over to the assembly. That, well, it should be pretty apparent that if it's staying on center or not, but because of the clearances of these guys, there's possibility that there'll be a slight misalignment. All right, selecting the point, selecting the origin, making those vertical, go ahead and hit OK. And then we can save that guy. All right, so here's where the configuration comes in. I have two items that same size block, same counterbores, but I want to manage these as a single part rather than having two separate parts. And we'll tinker a little bit in the assembly. So my default, I might want to have all of the common elements as a default, in which case I would just suppress both of those. When I come over to the configuration tab, so we have the feature tree, we have the property manager, we have the configuration manager, and at the very top, at the part name, I'm going to add a configuration, and this is going to be the M5 tapped holes. And depending on how I want to see this in the bill of materials, we might pick a slightly different naming set for those, but that'll get us started. And we can come over and unsuppress, go back to the default, they disappear. So it's an easier way, and especially if we have more geometry that we're suppressing, unsuppressing, it's an easier way to switch back and forth. Right, so add a configuration, and this is going to be the M12 tap tool. I'll still put the S on there, but that's okay. So we come back over here and we unsuppress, and then we can double check our configuration default, M12, M5, close enough. All right, so those two pieces, we'll see what the advantages and disadvantages of the configuration. As long as we have the two parts and those common items are pretty well defined, then we're in good shape.